Hey guys, welcome back to Home Built, and this week we tackle my favourite, wiring. Okay, those of you who have been following along will realise that I am going to be doing an electronic fuel injection conversion on this car. Now, standard this car comes with CIS, continuous injection system. It's a very, very early crude injection sort of. It's not a carby, but it's very difficult to modify, and by all accounts it works fine as long as it's completely standard and it's left alone and it's sort of maintained. But when you try and get anything else out of the engine, it's very difficult to work with. So some guys go over to carbies. I've had enough fun with carbies on the Datsun, and I think I'll give it a miss for now. I think EFI is going to be great. It's going to add a lot of usability to this engine. It's going to make it easier to start in winter. It's just going to start and run forever, hopefully. So a lot of you are asking what ECU I'm going to be using on this engine, and I've actually been talking to Link ECU. They're a Kiwi-based company. Basically, I was just going to do the simplest EFI conversion on this engine, and that was going to be using their basic Link Storm ECU, which is perfect for that. So the minimum sensors you usually need to convert one of these cars over to fuel injection, the computer needs to know where the crank is for the timing, and also where the cam is so that you know which phase of the engine it's on. So there's two of the sensors. You need a throttle position sensor so it can tell where the throttle is. You need an air temperature sensor is what they often use on individual throttle bodies, and a surface temperature sensor, which is something that a lot of ECU companies have never heard of, but it's common with these air-cooled 911 engines because we don't have water temperature, we have air temperature. We use the surface temperature, of the engine. And I think that's about it from memory. That's about all you really need to convert this over. It's very difficult with individual throttle bodies to get a MAP sensor to work. Some people think that they will. That's a mass airflow pressure sensor. Basically, that works off of the vacuum ports, but the trouble is because you've got 6 tiny little vacuum ports, you don't actually have a very good, reliable vacuum signal, particularly sort of at idle and things like that, from what I understand. So it's not really necessary on these on these types of conversions. I am far from an expert on any of this. This is the first time I've ever done any of this, and I'm learning as I go, which is why there was project creep, and Link have been very, very understanding and very helpful, because that was all the requirements I needed. So they're like, yep, our Storm ECU is going to be the best one for you. And then I changed something. I got talking to the guys at Raceworks and talking to Benny, and they're all suggesting that it's much better, much more efficient to go with a fly-by-wire throttle. So that means that I'm not going to have a cable. It's all going to be an electrically controlled by the ECU, which meant I had to send the Storm ECU back and get their next one up, which is the Extreme ECU. And they sent me that out, and they were very good about it, and was getting everything ready for that. And then also talking to Benny, and because I have no idea what I'm doing, I thought, oh yeah, I can just add wideband sensors. These things, these computers have lots of inputs. Surely you just add the sensors and just plug in the computer. What I have since learned is for wideband sensors, you actually need a lambda control module. And a lot of ECUs sell these as a separate thing. Usually they are just a separate unit. Link actually has on their bigger ECU again, the Thunder, they actually have dual internal lambda control. So they can run 2 wideband sensors, which is what I've got on this car. Because the exhausts stay completely separate until sort of inside the muffler, and it's not a very even run. Basically, I need 2 wideband sensors to monitor each bank, and the Thunder ECU is the one that can control all of that. You can get modules separately and have separate modules, but it's much cleaner and easier and better if you're doing it from the start to just start with the right thing and not keep sending it back to Link all the time. But they have been very, very good and very helpful. I really recommend dealing with them. They've been great. So that's where I'm up to with this. So now it means I actually have to start trying to work out where to mount it. Now, I actually haven't got the ECU yet, but I do have the wiring looms. Thankfully, the wiring looms are the same for all of them. You can just sort of swap the looms plug into all of them. Just the bigger ECUs obviously might need a couple more looms. Now, it is time to start getting back into this engine, and that means that I need to start tidying up the original wiring loom. I need to pull it apart and see what's on there that I'm going to keep and what's on there that I'm going to get rid of. And there's a lot of stuff on there that I don't need. Okay, so I've put the engine wiring loom on here, and I've connected up the sensors I'm going to keep using. So what I'm going to do now is I'm just going to go through and open the whole thing up, and that way I can take out the wires that I don't want, take them out of the entire loom, and keep the ones that I do want. So as you can see here, I went around and I re-taped together the loom and kept it in its basic shape. I just sort of put little bits of tape every so often, just so that I have the basic structure still there and it hasn't turned into a massive bird's nest. So now I can go through and find some of these things. I do actually have a wiring diagram for this engine wiring loom, so I can just go through, and the bits that I know I don't need, I'm just going to take them out of the entire loom now and get rid of them. Okay, so I've gone through now and I've cleaned up a whole bunch of the wiring. I stripped back most of the things that I don't need. It has been messed with a bit over the years. I don't know why people have changed it and what they've done to it, but I've sort of traced back most of the sensors that I need are now connected. So now I need to go through. There's just one particular wire here. This was an oil pressure switch, which had been tapped into, and something else joined into that line at a different stage, so I'm not sure why. So I'm going to splice that back together again, heat shrink it, and make sure it's a good solid connection, and then we can start moving forward on tidying the rest of this up. Alright, so I'm in here in the back seat of the 911 and working out where the ECU is going to go, and I've sort of pulled some of this carpet up that I laid in here, because the ECU is actually going to go against this back sort of upright here, so where your legs in theory would go in the back seat. Obviously I have a cage in here, there's no back seat in this car. This is also where I believe some of the other kits actually mount the ECU, so mounting it right there is a nice spot, gives me good access through to get the wiring loom through the car. So I'm going to have to sort of open some of this up now and cut my hole through so I can start passing through the wires and work out where my loom is going to run. And the undercar location is just up here, so here's the center tunnel right here, so this is the back of that spot. So now I just need to mark out and start drilling through some spots to put my loom through. So the first thing I need to do is to work out how to get power to the ECU, and the best way to do that, I need ignition on power. So I'm going to go through now and power up the car. I haven't got a good wiring diagram. I've got a bunch of different ones that are different things. They're not very clear. It's hard to follow. So the way I'm going to do it, I'm going to just power it up and find out where the power is being sent to the back. Test it manually, and then we can work out how to connect that up and then start connecting up the wiring to the ECU. Okay, so I pulled the whole panel out of the rear of the car, And I'm still trying to work out what connection I want to wire everything up to. I'm pretty sure basically what it'll end up being is this blue wire that goes to, this is the voltage regulator. So the alternator on this car has an external voltage regulator, similar to what the Datsun has. All modern cars now have an internally regulated alternator, so it's all in the one thing, but these old cars have this external voltage regulator. So that's going to stay. This is for the rear window heater that I no longer have. That's no longer connected, so I'm going to remove that. There's some of these wires here that were actually taped up from the factory by the look of things, so that's going to go. And I'll just get in here and start just disconnecting some of this wiring that I'm not using anymore. And I actually have this classic retrofit fuse panel in the back here. And this is going to come in quite handy because I no longer need any of this stuff, because one of them is for the rear window heater, don't have that. And also for the external heater blower fans that I don't have either. So those are now redundant. So I can use this really cool fuse panel to power my ECU. All right, here's something I've just stumbled across, and I'm wondering if some of you guys out there can help me with this. I've been looking for a good wiring diagram for this car. It's very difficult to find anything decent. One of the things I've just noticed is that coming from the alternator, coming into the this connection on the far end of this block, there's a red wire coming straight from the alternator, coming straight through, and this one in this case connected directly up to this fuse panel block. And there's also the red wire coming in from the battery side, in from the car, which has got full power. This went to a separate different fuse, but they don't actually appear to directly connect up to each other. Now, because I have removed these other things, I'm wondering, do I need to connect the red alternator wire up to the red rest of the loom so that there is a flow there? Let me know in the comments, because I have no idea. But as it is, I think I've got most of this sort of separated out here to what I need. So I'm going to leave this for now until I can work out exactly where I need to connect the power up, and I'll move on to something else. Alright, so what I've done here is I've put the wiring loom in through the route it's going to take, and it's gone into the inside of the cabin. I've given myself enough length there so that I can plug it in. I'm going to now put a loop of tape around the loom where it comes out of the firewall, if you want to call it that, down underneath here into the back of the car. And then I'm also going to put a piece of tape around where the loom comes out, where it's going to be level with the corner of the engine. So then I know the length of loom I need to leave for that part, and I can start lining it up with the engine itself and making the engine part of the loom and start connecting up things. So the Link ECU actually has two big main wiring looms, and that's a whole lot of wires. But I don't think it's not as daunting, I think, once I start getting into it, as it first appears. Most of them are very well laid out, or they're all very well laid out, and it has on the, I have a quick start guide here, and I've gone through and printed this out, and it shows you what every wire is for. They're all obviously well labelled and well marked, and then I've got a table here which I'll fill out as I go, marking in what each wire is connected to and what it does. It's all reasonably straightforward. Okay, so now I'm getting my head around things. To run this ECU and to run the engine, I'm going to run a bank of 3 relays in the back. Now, I'll just quickly run through. Those of you who don't know what relays are, I know most of you probably, this is sucking eggs, but basically this is an electronic switch. So, for example, the Datsun, I believe, didn't actually originally have a relay on the headlight switch. So basically, like any switch, you've got the power coming in. When you flick the switch, the terminals touch and the power goes to the headlights. The trouble is that the headlights use a lot of power. They take a lot of current, and the amount of current going through would burn out those switches points, and so running all the power through the headlight, the little headlight switch, it would burn them out. So the better way to do it is to run a smaller current. You just need a small current going through, and when you flick that switch, what that does is that'll send power to a relay, and the relay, as you can see, has 5 wires coming out of the bottom of it. Basically what it is when you flick that switch, it sends power to the relay, energizes the relay. The relay then has another switch inside itself, and it can have high power going into the relay, and the little switch will connect up the big wires together, basically, and you get lots of current. Hopefully that was that roughly summarizes what a relay does for you guys, but because I'm going to be running 12 coil packs, I really need a lot of current going to those coil packs, and I've decided to run it on 2 separate banks. What I'm going to do is I'm going to run the upper bank of coil packs on one relay and the lower bank on a second relay. So that way I've got some redundancy. For some reason one stops, one relay dies or whatever, the engine will still run on one lot of coil packs and it'll still be going. So there's some redundancy there, but it's also separating out the power usage. I think it's a good way to set it up. The other is going to be the main relay. So this is basically the initial. So as soon as you turn the ignition switch, it'll turn the relay on to power this. It'll power up the ECU, and it will also this relay will then power on the other 2 relays. So that is the way I'm going to wire it up. So now it's a matter of working out what I want to go where, and start actually making the power wires for the coil packs. Okay, so the way I'm going to make this loom and start bringing it all together is I've laid the first wires, the power and the ground wires for the coil packs, because these coil packs have 3 wires going to them. So they have a higher amperage power and ground, so that can that powers them, and then they have the low current trigger wire, which comes straight from the ECU. So this is the stuff that actually carries the power, and this is going to be the one wire shared through this circuit. And what I'm going to do is I'm going to run it. I've run it from the corner where I want to start, run it along, and go to the end pack first, and I'll cut it off here, and then I will start splicing into that wire along the run, and I'll show you how I'm going to do that. What I've got here is I've laid my wire out. I've already done one just up here, but I laid my wire the full length all the way to the end coil pack. And then I've gone back and I put one first splice here, and I'll show you how I make the splice over here. Now, you need to remember to put your heat shrink on beforehand. So I needed 2 heat shrinks here because there's 2 splices on before you actually make your first splice. So in this case, I want my splice about here. I'll take my wire strippers and I just bare the wires. So if you see there, I've actually bared the wires. I've opened it up a bit. I'll then take my power wire, work out the length I need, trim it to length, strip off the end, and with my bare piece of wire here, I will twist it onto the wire. And then I've got these little crimp splices from, these are from Raceworks, so you can get them from all over the place. You can even use the end of some of these other crimp terminals, but I don't like the coloured plastic ones. I like these solid type. Basically the way that they connect on, you've got this little splice here, put it over the wires, give it a bit of a squeeze, and then I crimp it on. And you can see here that it does a really nice folded crimp. That's super strong. That is not going anywhere. And then slide my heat shrink down over the top, heat shrink it on, and that is a good splice that's not going to go anywhere. That's the way I'm liking to do it. You want to make sure you get these sort of crimping pliers. Might be hard to see there on camera, but basically that that crimp is sort of a U shape like this, and you sort of bend it over a little bit by hand. But when you put the crimping pliers on it, it actually tucks these ends in and it bites right into the wires like that. and it's not letting go. That is a super strong connection. That's the way I like to do it. So I've got my basic loom here. I'll just get the heat gun out and shrink these bits of heat shrink, and then I can connect up my connectors to the end of it. So for the wiring now, you can see I've got my positive and negative here going through to the coils, and they're already spliced together. So the next thing I might do is run the power through to the injectors, which will run along in this same loom, and there'll be power wires going to each individual injector. Again, they're going to be spliced together and be one lot of power for the injectors because they're negatively switched, and that switch comes in from the ECU to each injector. So let's start making the power loom for the injectors. So these are the wires that are going to go through to my relays, and we have the wiring set up here. So the white wires are going up to the injectors, the red and black going down for the power and ground to the coil packs, and we have these looms all spliced together. So it looks like a bit of a mess, but trust me, it's doing quite well. I'm quite happy with how it's coming together. All right, I'm really happy with the progress we've made on this, on the wiring. Wiring is always a daunting task for me, and for my goal on this engine is I wanted to learn more and get a lot better at wiring. I'm much happier with the way that these splices come together. These are like super strong, nice and safe. They're never going to have a fault. I'm quite comfortable with the way that I've put them together, and I just want a nice, neat, organized system that works on this car. So I'm going to be doing up a wiring diagram to go with the car so that you can troubleshoot it in the future, and it's all going to be a thought out system. That's the plan anyway. And if you need any parts for Porsches, new, old, water cooled, air cooled, anything, make sure you compare the prices at PorschePartsByJeff.com. We can you can put in all your details in there, and I've already used it for a bunch of different things actually. It works really well. I'm quite impressed with what Ryan has done with that. If you want to help out the channel, please go down to Patreon. Joining on Patreon, it really helps us out, really helps keep me moving at this pace, getting the work done. So, all right guys, until next time, see you later.